Hey everyone, in this video we're going to cover the concept of antiderivatives. So antiderivatives is essentially going backwards on derivatives. So for example, these functions that I've given here are the derivative of something. So what are they? The question of antiderivatives is, what are these functions the derivative of? So what function did you take the derivative? So what was f of x that led you to have cosine x as the derivative? And so essentially you have to think backwards, right? What function gives you a derivative of cosine x? And that would be sine x, right? The derivative of sine is cosine. What function gives you a derivative of e to the x? That would be e to the x, right? When you check it, the derivative of e to the x is e to the x. What function do you differentiate to get a derivative of 1 over x? And that will be natural log of x. We'll come back to this one. And what function, when you take its derivative, do you get secant square? So you're kind of starting to hopefully see what antiderivative means. So if you have the derivative of something, where did it come from? So who has the derivative of secant square? That will be tangent. And what about this one? What function has a derivative of 8x cubed? So what was the function that gave us 8x to the third as its derivative? So this one may be a little bit harder to see, but this came from 2x to the fourth. Now look at this. When you take the derivative of 2x to the fourth, you bring the 4 down, general power rule. 4 times 2 is 8, and then you decrease the power by 1. So x to the third. So these will be almost the antiderivative. So if this is what you tried on your own, I will say you are almost there, right? 99% correct. And why is that? And why are you not 100% correct? So say for example, I'll give you the function g of x is sine x plus 17. What's the derivative of this function? The derivative will be just cosine x, right? Because the derivative of 17 is 0. So then you'll just have cosine x. What about if I have h of x equals e to the x plus 1,000? What's the derivative? What's h prime of x? E to the x. So when you have a constant, the derivative of a constant is just 0, so you don't see it in the derivative. So that means that all of these have a plus a constant, because we don't know if they had some sort of constant there, because when you take the derivative of that constant is 0, so you won't see it in the derivative. But going backwards, when you do the antiderivative, you have to always add plus a constant. And I said we were going to revisit this one. F prime of x equals 1 over x. Its antiderivative is ln of x, but what do we know about the natural log of x? The natural log of x has a restricted domain, right? The domain of ln x is from 0 to infinity. But here, we don't have a restricted domain. The antiderivative is the function 1 over x. And remember, 1 over x, what does that look like? You have the positive part of the hyperbola and then the negative. So, but then when we go, if we just leave it as ln of x, now I'm restricted the domain from 0 to infinity, but the original antiderivative doesn't have a restricted domain. So that means that we have to attach an absolute value here, so that x can be negative here, but then we can't take the absolute value of a negative number. I mean, we can't take the natural log of a negative number, so we put an absolute value of that. So whenever you see f prime of x equals 1 over x, and you're like, oh, there goes the derivative of ln of x, right? So the function here will be ln of absolute value of x plus c. So always make sure that you include the absolute value for the antiderivative of 1 over x. And now let's revisit this one, the 8x to the third, to get to that. So we essentially did the general power rule backwards, which is then going to give us the, oops, I don't know why I use a capital there, but hopefully I have no English majors in here, but if I do, I apologize for my capital letters in between a sentence. Anyway, so the general power rule for derivatives, what does it say? when you have the general power rule for derivatives, essentially we're taking the derivative with respect to whatever our variable is. So I'm just going to use x of x to the n. Then the general power rule says you bring the n down, so bring the power, so multiply by the power n times, and then decrease the power by 1. Right? So then if I was going to write our steps, we are essentially multiplying by the exponent, so multiply by the exponent. Right, I bring the exponent down and multiply by it, and then we decrease the power by 1. So then when I'm going backwards, then I'm going to get the general power rule for antiderivatives. So going backwards, what does that mean we're going to do? So my first step is, since I'm going backwards, I'm going to do the opposite of what I did here, right? So here I decrease, my last step was decrease the power by 1. So going backwards, that's going to be my first thing, but the opposite. So we're going to increase power by 1. And then instead of multiplying by the exponent, right, the opposite of multiply is divide, we're going to divide by the new exponent. So looking back at that problem that we had for f prime of x equals 8x cubed, then using the general power rule, f of x will be, what do we do? Increase the power by 1. So this will be 8x to the 3 plus 1, which is 4. And we divide by the new exponent. My new exponent is 4, so I divide by 4. So the original function one then is 2x to the 4th plus a constant. Don't forget about the plus c. So that's how I got the 2x to the 4 plus c. So essentially doing the general power rule backwards. So we have a general power rule for derivatives, and now we have a general power rule for antiderivatives. So let me summarize that. So your general power rule for antiderivatives essentially says that if the derivative of some function is x to the n, then the antiderivative f of x, the original function, then is x to the, add 1 to the exponent, to the n plus 1, and divide by the new exponent, n plus 1, and don't forget plus a constant. So this is the antiderivative. So antiderivative is essentially just you are given the derivative of something and you're going backwards to try to find the original function. What did you take the derivative of? So let's try some examples. So let's just start with this example. So if f prime is equal to this function, find the original f of x. Okay, so just like we did with derivatives, when I knew that I needed to use the general power rule, I had to rewrite my function. So the same thing is going to happen here. I need to rewrite 1 over x squared, so I can use the general power rule for antiderivatives. So I'm going to rewrite it and say f prime of x is e to the x minus 2x to the 5th plus x to the minus 2 minus 5. And now I can take the antiderivative. So then my f of x, the original function, what did I take the derivative of to get e to the x? E to the x, right? The antiderivative e to the x is e to the x. What about here? So here I'm going to use the general power rule. So I'm going to add 1 to the exponent, so it'll be 5 plus 1 divided by the new exponent. 5 plus 1 is 6. So divided by 6 plus x to the negative 2 plus 1. Negative 2 plus 1 is negative 1, so divide by the new exponent minus what's going on here with the 5. That's a constant, and I'm taking the antiderivative, right? So what did I take the derivative of to get just 5? And that will be 5x. And then plus a constant. So the other way you can think of it is when you have a constant, this has an x to the 0 in there. And so then you can use the general power rule on this. The antiderivative of x to the 0 will be add 1 to the exponent and divide by the new exponent. So you just get x. But always think of what did you take the derivative of to get just 5? And that will be 5x. And don't forget your constant. And then simplify it. So it'll be e to the x minus x to the 6 over 3, right? The 2 and the 6 reduced to 1/3, minus x to the minus 1, which is really 1 over x there, minus 5x plus c. So e to the x minus x to the 6 over 3 minus 1 over x minus 5x plus c. So this will be our antiderivative. Now, the nice thing about antiderivatives is that you can always check them. So check your work. So if you take the derivative of what you think the answer is, you should get what you started with. So the derivative e to the x is e to the x. The derivative of this will be minus 6x to the 5th over 3. The derivative of x to the minus 1 will be plus, right, bring the power down, so plus x to the minus 1, so minus 2. The derivative of 5x is minus 5. The derivative of a constant is 0. Do we get what we started with? 6 divided by 3 is 2. So e to the x minus 2x to the 5th plus 1 over x squared minus 5, and that is what we started with. So that is one of the really, really nice things about antiderivatives, is that when you're done, take the derivative and see if it's your original problem, because that's how you can check it. All right, let's try another example. Now this one, find the antiderivative of x cubed plus x minus pi, the whole thing divided by the square root of x. And now I'm using this notation, the f prime, but you could also be given the notation as dy dx equals. And this one, we're going to rewrite it. So I'm going to say x cubed over root x, the square root of x is really x to the 1/2, plus x over x to the 1/2. So I'm going to split up the fraction, minus pi over x to the 1/2. And continue rewriting it. Dy dx is, when you divide the same basis, you subtract exponents. So 3 minus 1/2 will be x to the 5/2, and then x to the 1 minus, or x to the 1 divided by x to the 1/2. So again, you subtract the exponent, so plus x to the positive 1/2, and this one we just need to bring the exponent to the top. And am I done rewriting? Looks that way. So now we can take the antiderivative. So f of x or y is, so now we do the general power rule for antiderivative. So add 1 to the exponent, so x to the 5/2 plus 1, and divide by that new exponent. And then plus x to the 1/2 plus 1, and divide by that new exponent, minus pi x to the negative 1/2 plus 1, and divide by that new exponent. If you can do those fractions in your head, you're fine. You don't have to do these steps, but I'm just kind of making sure I'm sure I know my work. And what does this become? X to the 1/2 over 1/2. Now dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. So dividing by 7/2 is really multiplying by 2 7ths. Dividing by 3/2 is the same thing as multiplying by 2/3. And then divided by 1/2 is really the same thing as multiplying by 2 over 1, so minus 2 pi square root of x. And what am I missing? Plus a constant, right? Plus c. Don't forget your plus c. And then how do you check it? Take the derivative and see if you get your original. So then this is our antiderivative. So let's try another example. So let's find the antiderivative of this function. So I'm giving a derivative, and notice that it's not always going to just be the general power rule. You have to know your other derivatives. So this is where things sometimes start to become confusing, because you have to know your derivatives forwards and backwards. So it's really important to know what you're doing. Are you taking the derivative, or are you taking the antiderivative? So being able to go backwards. So let's try this one. So I have my f prime. Do I need to rewrite anything? No, right? I don't know why I'm rewriting it then, but probably because I want to see it in my own handwriting. So this is our derivative. So my question is then, what is the function? What did I have to take the derivative of to get this. So let's remind ourselves of some derivatives. And speaking of knowing our derivatives forwards and backwards, let's see. If I have f and f prime, so if I have e to the x, what's the derivative of e to the x? E to the x, right? Here I have 2 to the x. What's the derivative of 2 to the x? The derivative is 2 to the x times the natural log of the base times the natural log of 2. So now what if I'm going, in this case, right, I'm going backwards. What if I have 2 to the x as my derivative? What is the antiderivative? And notice that I don't have the ln of 2, so that means that it's going to be 2 to the x over the natural log of 2. So that's what we're going to get here. So the antiderivative of 2 to the x is 2 to the x back divided by the natural log of the base. When you take the derivative, you're multiplying by the natural log of the base, so the antiderivative is the opposite of that. So it's 2 to the x divided by the natural log of the base. And then minus the antiderivative of secant square is tangent. And here we can use the general power rule. So 3x to the, add 1 to the exponent, so 4 plus 1 is 5, divide by the new exponent, and then for full credit, plus c. So don't forget your constant. So this will be our function, the antiderivative, and there's nothing to simplify. So let's try another example. So let's try our fourth example. Find the antiderivative of g prime of x equals this product. So because I'm taking the antiderivative, I don't have yet any sort of product rule or anything like that. So this is what I'm talking about. You have to make sure, what are you doing? Are you taking the derivative or the antiderivative? Here I'm taking the antiderivative. So let's multiply this out, right? So let's rewrite it so that we can then use the general power rule. So g prime of x is going to be, multiply this out. So I'm going to get x cubed minus 2x squared, and then plus x and minus 2. So that is rewritten, and so now I can take the antiderivative. So the backwards of the derivative, so general power rule, so add 1 to the exponent, so it's x to the 4th, divide by the new exponent, minus 2x to the 3rd over 3, plus x squared over 2, right? Add 1 to the exponent, divide by the new exponent, and a constant that must have come from minus 2x, and then plus c. Don't forget your c. And so that is the antiderivative. So a good thing to do is start reviewing all your derivatives and make sure that you know them forwards and backwards. Right, so you want to be able to recognize, like if I say the derivative of something is 1 over the square root of 1 minus x squared, then do you recognize that derivative? Yes, hopefully. Then y is inverse sine of x. And so in recognizing your all the ones that we have talked about, right? If dy dx is 1 over x squared plus 1, then you can say, oh, that is, you see this walking around the quad, and you're like, oh, there goes the derivative of inverse tangent of x. Not quite. What's missing? Plus c. Don't forget your c. Sometimes one of the things I say is, if you're a sports fan and you're watching sports and you're watching your favorite team and they do something good, what do? You cheer, right? So you jump from the couch or wherever, and then you go, yes! And so do that for yourself when you're solving antiderivative problems. Cheer for yourself as soon as you're like, oh, there goes the derivative of inverse tangent. Go, yes! But say it in Spanish, and then you won't forget your C. All right, I'll end there for part 1, and then in the next videos we're going to go over antiderivatives using higher order derivatives. Like if you're given the second derivative, how do you get back to the original function? If you're given the third derivative, how do you get back to the original function? And then if you're given what's called an initial condition. So if I say this is the antiderivative of a function, but I know, for example, g of 1 is 7. Then how do you deal with that? And when you have an initial condition, like in my example here, if I say g of 1 is 7, what that's going to do is going to help us solve for c, because then I will know g of 1, that means x is 1, so I can plug in 1, 1, 1, 1, is 7. That means that this value, the y value, is 7, and then I can solve for c. So that's how the initial condition works, but we'll do that in the next set of videos.